In some questions you're not actually given a diagram with which to work, and so you have to be able to draw a diagram that is going to represent your question, and you're going to use Pythagoras to solve the question. Do have a look down in the middle there, north, south, east and west, the points of a compass. That's generally how we start. I know that's in year 8 and probably in year 9 in geometry. We drew those and we dealt with those quadrants 90 degrees each, and together they added up to 360 degrees. The basis of drawing your right angle triangle right there. Exercise 22.05. Some really good questions in here just to cement your knowledge. Have a go. Please do questions 2, 4, 6, 8, 10 and 12, and do remember to mark your work when you're done. If you can do these questions, young people, you're heading for a good mark in the assessment. Do at least question 6 on the slide, but do have a go at the others if you would like. Do at least questions 8, 10 and 12. Pythagoras can be used in reverse to decide whether a triangle is right angled. So for that, of course, you'd have to have the measurements of the 3 sides. And if those 3 side lengths fit the rule of a squared plus b squared is equal to c squared, then you know for a fact that it is going to be a right angled triangle, that c is going to be 90 degrees. Work through this example. Down below, it is a triangle that's been drawn to scale, so see if you can use your ruler to work out those measurements and apply them to the formula, and you can see that once you've done that, there is also the formula on the right hand side. You can work out, and of course if your hypotenuse 66 squared is not equal to a squared plus b squared, 51 millimeters squared and 42 millimeters squared, then you know that this is not a right angled triangle. Do have a go. To cement your knowledge, have a go at exercise 22.06. Do at least questions 1, 2 and 3. Please do mark your work and check the answers. Exercise 22.07. Calculators introduced here, but I'm pretty sure you'll have been using one since the very start, so do go through that again, question 1 and 2, see how the calculator goes. But so again, I'm reasonably sure that you'll be pretty comfortable with using your calculator. For some practice relating to Pythagoras in 3-dimensional figures, please go to Ultranet. This is a screenshot of the Ultranet page. Learning intentions there, success criteria, and there is also a PowerPoint on the right hand side there. You can see it there, 3D Pythagoras, and there are also worksheets in that worksheet down below, so please have a look at this. I'll include the main slide from the PowerPoint in the next slide. This is the PowerPoint that relates to Pythagoras and 3-dimensional shapes. Remember, all the work up until this point has been in 2-dimensional shapes, so work through that, see if you can follow it. Again, it's logical, it does follow. If you are stuck, ask me, but be absolutely sure that you can visualize the shape and that you are able to apply the formula, put the values in the formula and get an answer. This is question 1 from the worksheets on Ultranet relating to Pythagoras in 3 dimensions. Please, I think there are about 7 questions. I'd like you to have a go at those. They are important for the assessment and also important for your understanding of the subject. And do keep in touch with me if you have any questions.